What if the next time you wanted to visit space, all you had to do was step into an elevator? No rockets, no launch pads, just a smooth ride straight up into the stars. It sounds like science fiction, but with humanity's growing hunger to explore the cosmos, the idea of making space travel as simple as taking an elevator isn't as far-fetched as it seems. In fact, scientists and engineers are already dreaming up ways to turn this vision into reality. Enter space elevators and orbital rings, two revolutionary concepts that could completely transform how we access space. One promises a towering tether stretching from Earth to the heavens, while the other envisions a colossal ring encircling our planet, acting as a cosmic highway. Both ideas aim to make space travel faster, cheaper, and more accessible than ever before. But here's the real question: which of these futuristic technologies has the potential to become a reality first? In this video, we'll dive deep into the science, challenges, and possibilities behind these groundbreaking ideas, exploring how they could shape humanity's future among the stars. So, buckle up, because the future of space travel might just be closer than you think. Imagine a structure so tall it reaches beyond the clouds, beyond the atmosphere, and even beyond the edge of space itself. A ribbon of technology stretching from the surface of Earth all the way up to a point tens of thousands of kilometers above. This isn't just a tower, it's a space elevator, a futuristic concept that could revolutionize how we travel to and from space. Picture this: instead of strapping into a rocket and enduring the bone-rattling forces of launch, you step into a sleek elevator car, press a button, and ascend smoothly into orbit. No explosions, no deafening roars, just a quiet, steady climb into the stars. But how does it work? At its core, a space elevator relies on a tether, a super strong cable anchored to Earth and extending into space. The key is balance. At the top of the tether, a massive counterweight, often placed in geostationary orbit, keeps the cable taut. Geostationary orbit is the sweet spot where an object orbits Earth at the same speed the planet rotates, effectively staying fixed over one point on the surface. This balance allows the elevator to remain stable, like a cosmic tightrope walker holding perfectly still. The idea isn't new. In fact, it dates back over a century to Russian scientist Konstantin Tsiolkovsky, who first proposed the concept in 1895 after being inspired by the Eiffel Tower. Decades later, science fiction legend Arthur C. Clarke brought the idea to life in his novel The Fountains of Paradise, envisioning a world where space elevators were as common as skyscrapers. Since then, the concept has captured the imagination of scientists, engineers, and dreamers alike, becoming a staple of futuristic visions. But building a space elevator isn't just about dreaming big, it's about solving some of the most daunting engineering challenges humanity has ever faced. The tether, for example, would need to be made of a material stronger than anything we've ever created. Enter carbon nanotubes, microscopic structures with incredible strength and flexibility. These tiny marvels could be the key to constructing a tether capable of withstanding the immense forces it would endure. Of course, the challenges don't stop there. From the risk of space debris colliding with the tether to the sheer scale of construction required, the path to building a space elevator is riddled with obstacles. But the potential rewards are staggering. A functioning space elevator could drastically reduce the cost of sending people and cargo into space, opening up new possibilities for exploration, industry, and even tourism. So, while the idea of a space elevator might sound like something straight out of a sci-fi movie, it's grounded in real science and real ambition. But as we'll soon see, it's not the only game-changing concept on the table. Now, let's talk about the elephant in the room, or rather, the tether in the sky. While the idea of a space elevator is undeniably thrilling, the reality of building one is a monumental challenge. Think about it, we're talking about constructing a cable tens of thousands of kilometers long, anchored to Earth and stretching into space. It's not just a matter of building something tall. It's about creating something that can withstand forces far beyond anything we've ever engineered. First, there's the issue of the tether material. To hold up under its own weight and the stresses of Earth's gravity, the tether would need to be made of a material stronger than anything we currently have. Carbon nanotubes have been proposed as a potential solution. These microscopic structures are incredibly strong and lightweight, but here's the catch. We've never been able to produce them at the scale or quality needed for a space elevator. In fact, the longest carbon nanotubes ever created are just a few centimeters long. Scaling that up to tens of thousands of kilometers, that's a leap we're not even close to making. And then there's the problem of space debris. Earth's orbit is cluttered with millions of pieces of junk, old satellites, rocket fragments, and other debris, all hurtling around at speeds of up to 28,000 kilometers per hour. A space elevator's tether would be a prime target for collisions, and even a small piece of debris could cause catastrophic damage. Protecting the tether would require advanced shielding and constant monitoring, adding yet another layer of complexity to an already daunting project. Weather is another major hurdle. On Earth, the tether would need to withstand hurricanes, lightning strikes, and even the occasional tornado. And let's not forget about sabotage or terrorism. A structure this massive and vulnerable could become a target for those looking to disrupt global infrastructure. Securing it would require unprecedented levels of international cooperation and security measures. Then there's the cost. Building a space elevator would require trillions of dollars in investment, not to mention decades of research and development. It's the kind of project that would need the combined resources of multiple nations, raising questions about who would fund it, who would control it, and how the benefits would be shared. Despite these challenges, the dream of a space elevator persists, driven by the promise of a future where space travel is as routine as taking a train. But what if there's another way? What if, instead of building a towering tether, we could construct a massive ring encircling the Earth, a structure that could serve as a cosmic highway, bypassing many of the challenges of a space elevator? Enter the concept of orbital rings, an alternative solution that might just be the key to unlocking the stars. So, what if instead of building a single towering tether, we could create a massive ring that wraps around the entire Earth? Imagine a colossal hula hoop encircling our planet, spinning at incredible speeds, held in place by the sheer force of its own motion. This is the concept of an orbital ring, a structure that could revolutionize how we access space, and it might just be the solution to some of the biggest challenges facing space elevators. At its core, an orbital ring is a giant loop made up of a series of connected segments orbiting Earth just above the atmosphere. Unlike a space elevator, which relies on a single tether anchored to the ground, an orbital ring uses centrifugal force, the same force that keeps water in a bucket when you swing it around, to stay in place. The ring spins fast enough to counteract Earth's gravity, creating a stable platform that could be used for launching spacecraft, building habitats, or even transporting people and cargo across the globe at incredible speeds. The idea of orbital rings isn't new. In the 1980s, British engineer and futurist Paul Birch laid out detailed proposals for how such a structure could work. Birch envisioned a ring made of superconducting materials, capable of carrying massive amounts of energy and supporting a network of tethers connecting it to the surface. These tethers would act like spokes on a wheel, allowing vehicles to travel up and down between Earth and the ring with ease. One of the biggest advantages of orbital rings is their material efficiency. Unlike a space elevator, which requires an impossibly strong tether stretching tens of thousands of kilometers, an orbital ring could be built using materials we already have. The ring itself would be relatively lightweight, and the tethers connecting it to Earth wouldn't need to support the same kind of immense tension as a space elevator's cable. This makes the concept far more feasible with current technology, or at least closer to feasible than a space elevator, but the benefits don't stop there. Orbital rings could serve as launch platforms for spacecraft, eliminating the need for traditional rockets. Instead of burning massive amounts of fuel to escape Earth's gravity, a spacecraft could simply hitch a ride on the ring, using its momentum to slingshot into orbit. This could drastically reduce the cost of space travel, making it more accessible for research, industry, and even tourism. And then there's the potential for habitats. An orbital ring could support entire cities in space with artificial gravity created by the ring's rotation. Picture floating neighborhoods, research stations, and even factories, all orbiting Earth just a few hundred kilometers above the surface. It's a vision that feels straight out of science fiction, but it's grounded in real physics and engineering principles. Of course, orbital rings aren't without their challenges. Building such a massive structure would require unprecedented levels of international cooperation and funding. There are also technical hurdles, like ensuring the ring remains stable and dealing with the risk of collisions with space debris. But compared to the challenges of a space elevator, many of these problems seem more manageable. So, while space elevators capture our imagination with their towering ambition, orbital rings offer a different kind of promise, one that might be more achievable in the near future. But which of these futuristic concepts has the edge, and could they even work together, complementing each other to create a new era of space travel? Let's dive deeper into the possibilities. Now, let's get into the nuts and bolts of orbital rings, because while the concept sounds like something out of a sci-fi blockbuster, it's rooted in real, tangible science. At its heart, an orbital ring is all about harnessing the power of physics to create a stable, functional structure that defies gravity. But how exactly does it work? Let's break it down. First, think about a spinning bicycle wheel. When you spin it fast enough, the wheel stays upright, resisting the pull of gravity. That's centrifugal force at work, the same force that keeps water in a bucket when you swing it around. An orbital ring operates on a similar principle. The ring spins at incredible speeds, generating enough centrifugal force to counteract Earth's gravity. This keeps the ring suspended in orbit, acting as a stable platform for all kinds of activities, from launching spacecraft to building habitats. But here's where it gets even more fascinating. To keep the ring stable and functional, engineers would rely on magnetic levitation, a technology we're already using in high-speed trains like Japan's maglev. Superconductors, materials that can conduct electricity with zero resistance, would line the ring, creating powerful magnetic fields. These fields would interact with magnets on the tethers connecting the ring to Earth, allowing vehicles to travel up and down without friction. It's like a cosmic elevator, but instead of cables, it's powered by magnets. Now, let's talk materials. Unlike a space elevator, which requires a single, impossibly strong tether, an orbital ring could be built using materials we already have. The ring itself would be made of lightweight, durable alloys, while the tethers could use high-strength composites. Superconductors, though still expensive and challenging to produce at scale, are already a reality. This makes the concept of orbital rings far more feasible with current technology, or at least closer to feasible than a space elevator. Energy is another key factor. Orbital rings would require a significant amount of power to maintain their spin and magnetic fields, but the energy requirements are surprisingly manageable compared to the constant strain on a space elevator's tether. Solar panels or even nuclear reactors could provide the necessary energy, making the system self-sustaining over time. Construction, however, is where things get tricky. Building an orbital ring would be a massive undertaking requiring decades of work and trillions of dollars in investment. But here's the kicker: compared to a space elevator, the timeline might actually be shorter. Why? Because orbital rings don't rely on a single, fragile tether. Instead, they're modular, built piece by piece in orbit and assembled over time. This modular approach reduces the risk of catastrophic failure and allows for incremental progress. Of course, orbital rings aren't without their challenges. Space debris, for example, is still a major concern. A collision with even a small piece of junk could destabilize the ring or damage its delicate superconducting components. Weather and atmospheric conditions on Earth could also pose risks to the tethers, requiring advanced shielding and monitoring systems. And then there's the question of international cooperation. Building an orbital ring would require unprecedented collaboration between nations, raising questions about funding, control, and access. But if humanity can overcome these hurdles, the rewards could be astronomical. So, while orbital rings might not have the same towering grandeur as space elevators, they offer a more practical, achievable path to revolutionizing space travel. But how do these two concepts stack up against each other? And could they even work together to create a new era of exploration? Let's explore that next. So, we've painted a pretty exciting picture of orbital rings, a cosmic highway that could revolutionize space travel. But let's not get ahead of ourselves. Building something this ambitious isn't just about dreaming big. It's about tackling some of the most complex challenges humanity has ever faced. And when it comes to orbital rings, those challenges are as vast as the structure itself. First, there's the sheer scale of the project. We're talking about constructing a ring that encircles the entire Earth, a structure tens of thousands of kilometers in circumference. To put that into perspective, the International Space Station, one of humanity's most impressive engineering feats, is just about 100 meters long. An orbital ring would dwarf it, requiring millions of tons of materials and decades of construction. And unlike the ISS, which was built piece by piece in orbit, an orbital ring would need to be assembled with pinpoint precision, ensuring every segment aligns perfectly to maintain stability. Then there's the issue of space debris. Earth's orbit is already crowded with thousands of satellites and millions of pieces of junk, all moving at breakneck speeds. An orbital ring would be a massive target, and even a small collision could have catastrophic consequences. Imagine a single piece of debris, no bigger than a pebble, slamming into the ring at 28,000 kilometers per hour. The damage could destabilize the entire structure, sending shockwaves through the system. To mitigate this risk, engineers would need to develop advanced shielding and debris tracking systems, but even then, the threat would never be fully eliminated. Environmental impact is another concern. Building an orbital ring would require launching massive amounts of material into space, which could have significant effects on Earth's atmosphere and ecosystems. Rocket launches, even with reusable technology, produce greenhouse gases and other pollutants. And while the long-term benefits of an orbital ring might outweigh these costs, the short-term environmental toll could be substantial. But perhaps the biggest hurdles are political and economic. Constructing an orbital ring would require trillions of dollars in funding money that would need to come from multiple nations working together. Securing that level of international cooperation is no small feat. Just look at the International Space Station, a project that took decades of negotiation and collaboration between 15 countries. And even then, it was fraught with challenges, from budget disputes to shifting political priorities. An orbital ring would require even greater unity, raising questions about who would fund it, who would control it, and how the benefits would be shared. Historically, large-scale engineering projects have always been a mix of ambition and compromise. Take the Panama Canal, for example, a project that reshaped global trade but came at a tremendous human and environmental cost. Or consider the Apollo program, which achieved the impossible by landing humans on the moon, but was fueled by Cold War competition rather than pure scientific curiosity. These projects remind us that grand visions often come with grand challenges, and Orbital Rings would be no exception. So, how does this compare to space elevators? While both concepts face immense obstacles, Orbital Rings might have a slight edge in feasibility. Unlike space elevators, which rely on a single, fragile tether, Orbital Rings are modular and could be built incrementally. They also don't require materials as advanced as carbon nanotubes, making them more achievable with current technology. But that doesn't mean Orbital Rings are a sure thing. Both ideas are still firmly in the realm of theory, and it's unclear which, if either, will become a reality first. The truth is, both space elevators and Orbital Rings represent the kind of bold, boundary-pushing thinking that could redefine humanity's relationship with space. But as we've seen, turning these dreams into reality will require more than just brilliant engineering. It will demand unprecedented collaboration, innovation, and determination. So, which of these futuristic concepts has the edge, and could they even work together, complementing each other to create a new era of space travel? Let's explore that next. So, we've explored the incredible potential of both space elevators and Orbital Rings, but how do they stack up against each other? Which one is more feasible, and which could truly revolutionize space travel in the near future? Let's break it down side by side, weighing the pros and cons of each approach. First, let's talk about cost. Building a space elevator would require trillions of dollars, largely due to the need for advanced materials like carbon nanotubes, which we still can't produce at the necessary scale. Add in the costs of anchoring the tether, constructing the counterweight, and maintaining the system, and the price tag becomes astronomical, literally. Orbital Rings, on the other hand, might be slightly more budget-friendly. While they'd still cost trillions, they rely on materials and technologies we already have, like superconductors and lightweight alloys. This makes them a more realistic option, at least in terms of upfront investment. Next, construction time. A space elevator would likely take decades, if not centuries, to build. The sheer scale of the project, creating a tether tens of thousands of kilometers long, is mind-boggling. Orbital Rings, while still a massive undertaking, could be constructed incrementally. Think of it like building a bridge. You start with one section, then add more over time. This modular approach reduces the risk of catastrophic failure and allows for gradual progress, making Orbital Rings a more achievable goal in the near term. Technological requirements are another key factor. Space elevators demand breakthroughs in material science, particularly in developing carbon nanotubes strong enough to support the tether. We're not there yet, and it's unclear when or if we'll reach that point. Orbital Rings, by contrast, rely on technologies we've already mastered, like magnetic levitation and superconductors. While scaling these up would be challenging, it's a hurdle we're far closer to overcoming than the material challenges of a space elevator. Now, let's talk risks. Space elevators face significant dangers, from space debris collisions to weather-related damage on Earth. A single break in the tether could send the entire structure crashing down with catastrophic consequences. Orbital Rings aren't immune to risks. Space debris is still a major concern, but their modular design makes them more resilient. If one section is damaged, the rest of the ring could remain functional, reducing the likelihood of a total system failure. So, which one is more achievable? Based on current technology and resources, Orbital Rings seem to have the edge. They're more modular, rely on existing materials, and could be built incrementally. Space elevators, while undeniably awe-inspiring, remain a distant dream dependent on breakthroughs we can't yet predict. But here's the thing, both technologies offer incredible benefits for humanity. A space elevator could make space travel as routine as taking an elevator, opening up new possibilities for exploration, industry, and even tourism. Orbital rings, meanwhile, could serve as launch platforms, habitats, and global transportation hubs, revolutionizing how we interact with space and each other. The truth is, we don't have to choose. These two concepts aren't mutually exclusive. They could complement each other, creating a future where space travel is faster, cheaper, and more accessible than ever before. Imagine a world where orbital rings serve as cosmic highways, while space elevators provide a direct route to the stars. Together, they could unlock a new era of exploration, innovation, and discovery. So, while the debate between space elevators and orbital rings is fascinating, the real question isn't which one is better, it's how we can work together to make both a reality. Because when it comes to reaching for the stars, humanity's greatest strength has always been our ability to dream bigger and then turn those dreams into reality. What if the key to unlocking humanity's future in space wasn't just about building bigger rockets, but about reimagining how we get there in the first place? Space elevators and orbital rings aren't just futuristic concepts, they're potential game changers that could revolutionize space exploration, commerce, and even how we live our lives. But what exactly could these innovations make possible? Let's dive into the incredible benefits they could bring to the table. First, let's talk about cost. Right now, launching anything into space is expensive, like really expensive. Sending a single kilogram of payload into orbit can cost tens of thousands of dollars. That's why missions to the Moon, Mars, or beyond are so rare and resource-intensive. But what if we could slash those costs by a factor of 10 or even 100? That's the promise of space elevators and orbital rings. By providing a more efficient way to reach orbit, these technologies could make space travel as routine as air travel. Imagine a world where launching satellites, building space stations, or even sending supplies to Mars becomes affordable and commonplace. This cost reduction could open the door to entirely new industries. Take asteroid mining, for example. Asteroids are packed with precious metals like platinum, gold, and rare earth elements materials that are increasingly scarce on Earth. With cheaper access to space, companies could send robotic miners to extract these resources, fueling a trillion-dollar industry and solving critical shortages back home. Or consider space-based manufacturing. In the microgravity environment of orbit, we could produce materials and products that are impossible to make on Earth, from ultra-pure crystals for electronics to advanced alloys for construction. Then there's space tourism. Right now, a trip to space is a luxury reserved for billionaires and astronauts, but with space elevators or orbital rings, that could change. Picture this, you book a ticket, step into a sleek elevator or shuttle, and within hours you're floating in zero gravity, gazing down at Earth from the edge of space. It's not just a dream. Companies like SpaceX and Blue Origin are already laying the groundwork for space tourism, and these technologies could make it accessible to millions. But the benefits don't stop there. Space elevators and orbital rings could also accelerate humanity's push toward the stars. NASA's Artemis program aims to return humans to the Moon by the end of this decade, with plans to establish a sustainable lunar base. SpaceX's Starship is designed to carry humans to Mars, potentially paving the way for a colony on the Red Planet. These ambitious goals require a steady flow of people and supplies, and that's where these innovations come in. By drastically reducing the cost and complexity of space travel, they could make missions to the Moon, Mars, and beyond not just possible but routine. And let's not forget about colonization. Imagine a future where humanity isn't confined to Earth. With space elevators and orbital rings, we could build self-sustaining habitats in orbit, on the Moon, or even on Mars. These colonies could serve as stepping stones for further exploration, allowing us to venture deeper into the solar system and beyond, but the implications go even further. By making space more accessible, these technologies could unite humanity in ways we've never seen before. Think about it, space exploration has always been a collaborative effort, from the International Space Station to the Artemis Accords. Space elevators and orbital rings could take that collaboration to the next level, bringing nations together to tackle challenges that no single country could solve alone. So, while the technical hurdles are immense, the potential rewards are even greater. Space elevators and orbital rings aren't just about reaching the stars, they're about transforming how we live, work, and explore. They could spark a new era of innovation, prosperity, and discovery, reshaping humanity's future in ways we can barely imagine. But as we look to the stars, one question remains: how do we get from where we are now to that bright future? What will it take to turn these bold ideas into reality? Let's explore that next. So, what does the future of space transport look like? If the past century has taught us anything, it's that humanity's capacity for innovation knows no bounds. From the first powered flight to landing on the Moon, we've repeatedly shattered the limits of what's possible. And now, as we stand on the brink of a new era, the possibilities are more exciting and more transformative than ever. Imagine a world where space travel is as routine as hopping on a plane. A network of orbital rings encircles Earth, acting as cosmic highways that connect us to the Moon, Mars, and beyond. Space elevators rise from the equator, their tethers glinting in the sunlight as they ferry people and cargo into orbit. This isn't just science fiction, it's a future that could be within our grasp thanks to emerging technologies and scientific breakthroughs. Let's start with material science. The development of stronger, lighter materials is key to making structures like space elevators and orbital rings a reality. Carbon nanotubes and graphene are already showing promise with their incredible strength-to-weight ratios. But what if we could go even further? Imagine self-healing materials that repair themselves after damage, or metamaterials that can manipulate light and energy in ways we've never seen. These advancements could revolutionize not just space transport, but construction, manufacturing, and even medicine. Then there's robotics. Building massive structures in space will require armies of autonomous robots capable of working in harsh environments with minimal human oversight. Advances in AI and machine learning are making this possible, with robots that can learn, adapt, and collaborate on complex tasks. Picture swarms of robotic builders assembling orbital rings piece by piece, or drones inspecting and repairing space elevators with pinpoint precision. These technologies aren't just futuristic, they're already being tested in labs and factories around the world. Artificial intelligence will play a crucial role too. From optimizing launch trajectories to managing the logistics of space habitats, AI could streamline every aspect of space transport. Imagine an AI system that predicts and prevents equipment failures before they happen, or one that coordinates the movement of thousands of spacecraft in orbit. These systems could make space travel safer, more efficient, and more accessible than ever before. But technology alone isn't enough. The future of space transport will also depend on collaboration between nations, industries, and even private companies. SpaceX, Blue Origin, and other pioneers are already pushing the boundaries of what's possible. But the scale of these projects will require unprecedented levels of cooperation. Think of it like the International Space Station, but on a global scale. Governments, corporations, and research institutions will need to work together, pooling resources and expertise to turn these bold ideas into reality. And let's not forget the ethical and societal implications. As we venture further into space, we'll need to grapple with questions about ownership, access, and responsibility. Who gets to use these technologies and who benefits from them? How do we ensure that space exploration doesn't exacerbate inequalities on Earth? These are complex issues, but they're also opportunities to create a future that's not just technologically advanced, but fair and inclusive. So, what's next? The future of space transport is a canvas, waiting for us to paint it with bold strokes of innovation and imagination. Whether it's orbital rings, space elevators, or something we haven't even dreamed of yet, one thing is clear: the stars are no longer out of reach. They're calling to us, inviting us to explore, to build, and to dream. And if history is any guide, humanity will answer that call not just with rockets, but with the kind of ingenuity and determination that has always defined us. The question isn't if we'll get there, it's how, and the answer lies in the choices we make today. So, what kind of future do we want to create? One where space is a playground for the privileged few, or one where it's a shared frontier open to all? The possibilities are endless, and the journey is just beginning. So, where does this leave us after diving deep into the science, challenges, and possibilities of space elevators and orbital rings? One thing is clear: these aren't just wild ideas, they're potential game changers that could redefine how humanity interacts with space. Space elevators, with their towering tethers reaching into the heavens, promise a future where traveling to orbit is as simple as stepping into an elevator. Orbital rings, on the other hand, offer a cosmic highway encircling Earth, a platform for launching spacecraft, building habitats, and even revolutionizing global transportation. Both concepts aim to make space travel faster, cheaper, and more accessible than ever before. But let's not sugarcoat it: the road to making these technologies a reality is paved with immense challenges. From the need for groundbreaking materials like carbon nanotubes to the risks posed by space debris and the sheer scale of construction required, these projects demand innovation, collaboration, and determination on a scale we've never seen. Yet the potential rewards are staggering. Imagine a world where space travel is as routine as air travel, where asteroid mining fuels a trillion-dollar industry, and where colonies on the Moon and Mars are no longer the stuff of science fiction. The question isn't just if these technologies are possible, it's when. Will we see space elevators or orbital rings in our lifetime? The answer depends on how quickly we can overcome the technical, financial, and political hurdles standing in our way. But if history has taught us anything, it's that humanity thrives on solving the impossible. From the Wright brothers' first flight to landing on the Moon, we've repeatedly turned dreams into reality. And now, as we stand on the brink of a new era, the stars are closer than ever. So, what do you think? Will space elevators or orbital rings become a reality in your lifetime? Could these technologies work together to create a future where space travel is as common as driving a car? Share your thoughts in the comments below. We'd love to hear your vision for the future of space exploration. And if you're as excited about these possibilities as we are, don't forget to subscribe and hit that notification bell for more deep dives into the technologies shaping our tomorrow. The future of space travel isn't just about rockets and launch pads, it's about reimagining how we reach the stars. And whether it's through towering tethers or cosmic rings, one thing is certain: the journey ahead is going to be extraordinary. So keep dreaming, keep exploring, and who knows, the next giant leap for humanity might just be closer than we think.